Hey everyone, Doug here with Process Technology out of Salt Lake City, Utah. Simple question. What defines a process transmitter? Most manufacturers talk about the bells and whistles, which are essentially features, but these features don't always translate into real benefits. Manufacturers also overlook talking about a lot of the actual design elements. Hang with me and let's take a deep dive into what defines a quality process transmitter. I'm breaking this down into three parts. Part one is going to be form function. Then we're going to talk about data integrity. And then lastly, operator experience. This video is part one, so let's get busy. An example of form function is multi-parameter. Years ago, a process transmitter was specific to a single parameter. You literally had to order 3 different models just to measure pH or dissolved oxygen or conductivity. Advent of multi-parameter led to now being able to order one model for numerous parameters. For example, this M400 from Mettler-Toledo literally can be a pH and ORP, or dissolved oxygen, whether it's polarographic or optical, or 2-electrode conductivity, or 4-electrode conductivity, or dissolved CO2, or possibly even a TDL, tunable diode laser with numerous gas measurements, all based upon what sensor is physically connected to the transmitter. Let's see multi-parameter in action.
We see on the display a pH sensor showing actually pH and ORP at the same time. By the way, that's a single sensor with all these electrodes using up a single channel from a single sensor, simultaneous measurements. So we've got pH on our display. Let's disconnect our pH sensor. We'll see how the digital technology recognizes there's no sensor connected. We can accept that. All the dashes just mean there's nothing connected to the sensor. There's no values displayed. Now we take our dissolved oxygen sensor, connect that. It's now prompting me, hey, you have a different sensor connected. You sure you want this? I'm going to just say yes, wait for the data to load. And note, the transmitter is really configured now for dissolved oxygen. So the sensors are the master. Transmitter becomes a slave. The transmitter gets configured. Sensor, if it's an oxygen sensor, will change the display to default values. Its primary value, which is DO, temperature, the health of the sensor is actually displayed here as well. All the calibration data is uploaded. We wanted to look at that calibration data for that sensor. Here it is.
That's pretty cool, right? True multi-parameter is what you just saw, not having to order and install a module that is extra. That concept is 20 years old technology. Another form function quality design is something as simple as how the transmitter front operates. Simply put, captive screws and hinged front.
The front actually will come away and not fall off. It's actually hinged. The screws are remained attached. This may seem trivial, but if you're 2 stories up on open grading, and you're trying to install a new transmitter, it's very common for models to actually have screws that are not captive. So you lose screws from 2 stories up. Where do you set the front when you're trying to wire in a new cable to a new transmitter, etc.? It's very challenging. Something as simple as having a hinged front and captive screws makes all the difference for an operator's positive experience.
Another form function quality design is having smart and variable power supply.
Having a smart variable power supply is pretty beneficial when you're trying to power the transmitter. And you can see here from the label that this transmitter will accept either AC or DC. That's not always that common, 100 to 240 volt AC or 20 to 30 volt DC. And then those wires are simply landed right here. You don't have to specify as an option or a different part number just to deal with different power supplies.
Another form function quality design is having sufficient analog outputs, relays, and even built-in PID for control.
As you can see here, this 2-channel instrument actually has 4 analog outputs here and 4 more here. So a total of 8 analog outputs. Got sufficient relays. All those are wired directly into these terminals. This transmitter also has standard offering of PID. So if I want to have a standalone NEMA 4X enclosure doing all my control that I don't want to have to rely upon a DCS, I go into the configuration, go to page 3 where I've got my PID control menu. I'm going to use PID number 1. I got to pick the channel I'm on. Let's just say I'm going to go channel 1, which is my pH probe. And then I have all my parameters I can set for my PID control. It's that simple.
Another form function quality design is how easy is it to land wires? This is a big one. Recall when this was the norm? Surprisingly, there are still process transmitter manufacturers still using this design. This is from last century, people.
Landing wires on transmitters historically has been a real pain. You saw the image showing the printed circuit board with actual terminal strips mounted to the board with tiny set screws. That's such a thing of the past. Nowadays, we have very simple interaction with just push in, and there's my wiring. So when I want to wire this transmitter, it's as simple as pushing in on the orange piece, put my wire in there, let go. Simple.
A quality process transmitter has all of these as standard, not options you have to order and pay for. Mettler-Toledo is the only supplier that checks all these boxes. Thanks for your time and stay tuned for part 2, Data Integrity.